In this video, we discuss some of the tools and approaches that I use when I prototype circuits using solderless breadboards. I wanted to make more videos of some of the projects and things I've been working on, but I realized it's probably a good idea to go back and just kind of give an overview of how breadboards and prototyping and the kind of tools and setup you need to be able to do fun projects like this. One of the first things that I wish I had gotten many years ago, but only recently discovered, is these things called a silicon mat. It's basically heat proof, so you could solder directly on it or use glue guns or heat guns. It's also flexible and easy to clean. It has these little pockets or indents so you could put components. It's kind of like a flexible border or tray. It helps me keep things from rolling off my desk. And it's a good spot to have little bits of wires or components without having them get lost with other junk on my desk. This is a solderless breadboard. It's a good way to have components electrically connect together without having to solder them or fix them together permanently. It's basically for temporary construction as you're figuring things out or designing the circuit or tweaking the values of the components you're using. I was going to explain how a breadboard works and why it's a useful thing, but I actually found a very good video that's already been done. I'll put the link in the description, but there's this other site called Science Buddies. They have a good introduction and use case for breadboards and how breadboards work and when you'd use breadboards in your projects. And they do an excellent job of going over all the things that I was going to talk about anyways. So rather than me just doing it all over again, I'll just send a link to go watch this video. The next thing we need if we're starting to build circuits is some kind of power source. When you're first starting out with basic circuits like resistors, diodes, transistors, LEDs, the exact voltage of what you're going to power your circuit is not critical. It's usually just fine to use a bunch of regular AA batteries in a regular AA battery holder like this. All I've done here is solder on little posts to the end of the wires that can be easily pushed into the breadboard. As we get into more complicated circuits where we do have specific requirements for voltages and sometimes even need more voltages, I highly recommend finding a good, inexpensive, adjustable bench power supply and actually finding probably more than one because sometimes you want to have different voltages. Another good idea, if you are serious about breadboarding, there's actually a lot of projects out there that now make small little modules that plug directly into a solderless breadboard right onto the power rails, and they have various different configurations allowing you to have a barrel connector, USB input, one voltage in, and then there's little jumpers or settings to have 3.3, 5 volts, other voltages output. And this is very convenient for powering small things like Arduinos, etc. I recommend finding something that suits your style or your needs. Having a power supply that just works and does what you need to do is very important because for things like this, you just want to set it and forget it and know that it works. My experience of using batteries is they always fail me. They give inconsistent results, especially over time. Over a day as I'm working on circuitry, they just run low, and then it's hard enough to try and design a circuit, but also have to worry about why it's not working. It turns out it's because, the batteries died. Batteries are good for when you've already figured something out and you want to make your stuff portable to take it to school, to show it off to friends. The next thing I like to do for breadboarding is have a good set of solid conductor wire. Now, I know the breadboard tutorial video that I linked, you could buy pre-made jumpers of various lengths, and that's a good way to get into things. But after a while, I find I like to make a bunch of wires that are whatever length I need, and I don't like to play with the pre-cut wires of the standard length. It makes my breadboards a lot neater to have wires routed exactly where I want. Here I only have two colors, red and black, but I know you can get spools of wire just like this in different colors. I recommend a good pair of needle nose pliers. These are a more recent addition to my collection. I used to have a pair that were straight. These ones have a little bit of a bend on the end. I actually find I prefer these a little more just because it helps me to kind of get in around wires that are already on the breadboard. I recommend a good pair of angle cutters. You really want to have the angle cutters like this that are flat on one side. Now this is also important later on when you start soldering components to actual circuit boards. You want to use something like this to cut the leads of the component after you soldered it to get a really nice finished product. I really like one of these multi-tool stripper or crimper tools. I use the strip guides here with several standard gauges of wire. And then of course it has the built-in cutters. The only problem with this style is you have to gauge and measure how far you're cutting off the insulation yourself. It's a manual thing you got to do by hand every time. Now the advantage of these kind of strippers is they are very inexpensive, but you have to do more work yourself. Now an upgrade from the simple cutter tool is a fancy wire stripper like this one. In the jaws, there's an adjustable gauge that you can set for how much wire to strip off the end. You put the wire in up against the stop gauge here. Then you squeeze the handle. The vise clamps down. Those little blades cut the insulation. It has like a spring force to kind of just push in hard enough to strip the insulation for whatever gauge of wire you have. It doesn't work for really small gauges of wire, but for the kind we use on breadboards, it's usually just about right. You pull the handle grip all the way, and the little blades pull back and rip off the insulation just the right amount that you've measured. Another feature I find handy is there's a built-in cutter blade on the top. As you squeeze the handle, a cutter blade comes out. We can use this to cut the wire. So with just having this tool in your hand, you could cut and strip wires just the same way you would with the simple strippers. What I usually like to do when I'm starting a breadboard project is just go ahead and build a bunch of wires of kind of the lengths that I know I'm going to use. Now the purpose of my video is to kind of go an overview of all the tools and equipment that I feel is essential when you're doing prototyping. I highly recommend a nice book, something that stays open on your workbench without it closing on its own. This is one of those coily back books that does stay open. I also recommend to get a pack of like Sharpie markers, different colors. Having different colored pens lets you draw different parts of the schematic. For example, you could have component values in one color, you could have the component symbols in a different color, and you could have notes or observations or doodles in another color. And after a while, when you find a color scheme that you like, it becomes easier for you to quickly glance at a page or go back in your notes and pick out details that are important without having to reread or spend a lot of time figuring things out. Because over time, you come back to something you built a while ago and you want to remember what you did. I recommend a good calculator. I know a lot of people have smartphones and those have calculators on them, obviously, but there's something about a real calculator that's not a phone that's just is useful to me. Multimeters. You can get a good expensive bench multimeter. I just get these inexpensive ones like from Canadian Tire. I always like to keep a couple on hand because if you want to measure two different things like current and voltage at the same time, you basically need more than one multimeter. Now, in addition to multimeters, I feel it's important to have a bunch of different probes. The pointy probe is useful as it's a very fine point. In this case, the point length can be adjusted depending on how long you want to have sticking out from the handle. These are useful for sticking into the breadboard to do an instantaneous measurement. It's not useful for leaving it connected, however, because these little points don't really stick in. They don't quite fit on their own. They're just small enough to fit through the plastic top and to contact the metal. The alligator clip style leads are very useful for holding onto components, for example, to measure a resistance. I find they're kind of inconvenient though if you're trying to hook them onto the breadboard, because you always need to have some kind of jumper wire like this, and then you have the alligator clips just dangling loose on the edge. I find this is bad because the clips have their own weight and they move around and they can bump into other clips and short themselves out or just rip the wire out of the breadboard altogether. What I found I like to do is that you can just buy these banana plugs, or as I've done here, liberate them from another kind of probe. I like to solder just a regular wire to the banana plug and then one of those little connector pins on the end with the heat shrink tubing. And I'm basically making a probe that'll go into my multimeter, but then fits directly into my breadboard. To me, this is great because I could wire up a voltmeter or a current meter. I don't have to deal with the alligator clips coming loose or touching each other, and I don't have to deal with holding the probe by hand into the breadboard. Now, for larger components that you want to use but don't actually fit into the breadboard, I find putting little wires like this onto them. Here I have those connector pins again. I'm not sure what these are called. I just found them on DigiKey. They call them connector pin receptacles. There's the part number. the wire, I like to use this really thin stranded wire. Finally, you want the heat shrink tubing. Here's a close-up of the pin soldered with the heat shrink tube over top of the wire. Of course, I guess it's probably worth mentioning that if you want to make those little jumper wires and little leads on things, you totally need to have a soldering iron. Finally, for solder, I like to use the really fine electronic solder. Well, that's all I have for now. Hope that's a good overview or ideas of what kind of tools you need to get set up and get going on building stuff with breadboards. Thanks for watching.